is here. Okay. So the set object or the set data structure lets you store unique values of any type. And we're going to see what that means and whether they're primitive values or object references. Cool. So let's start here. What are other data structures that allow you to have unique values? Only unique values. Just unmute and say it out loud. Or unique unique members.
Is it an array? Does that count as a data structure, or?
Yes, an array is a data structure, and that's a valid point. That is correct. And I guess like the way I asked the question can be a bit too broad. Yeah, in an array you can store unique values, but in an array you can also have duplicate values, right? What's the other data structure where you cannot have duplicates?
An object.
An object, that's correct. And what? Oh, Ben is here. What is any others that come to mind? Trying to think. Oh, actually no. So what are the characteristics of an object? Or
it has keys and values, and that the keys are individual and unique.
That's correct. Anything else? Anybody else?
No, anybody else? Sorry.
Constant lookup.
Constant lookup on keys. That is correct. Actually, we should be taking note of some of this. Let's just do it here. Objects. Unique keys. Constant lookup by constant time. Lookup by key. Okay. We're gonna be doing some comparison in between the object and the set, and this can come handy. Now Ben is here. I want to ask for who wants to go with Ben, and I can create the breakout room. Okay, actually, let me stop share because I can't see you. Okay, I see some thumbs up. Yeah, give me a thumbs up if you want to go with Ben. I see 2. Okay. Anybody else? Let me know.
What are they working on?
Ben, what will you be working on today? I'm not sure. Maybe Ben is not currently on his computer. Let me see. Or maybe no. Ben, are you with us? Yeah. Maybe he stepped away momentarily. I just opened the breakout rooms. I guess so. You can hang on until he goes there, and then you can go. Okay. Let's return here. Cool. So objects have unique keys, constant time lookup by key, and we were talking about the set. This zoom. Okay, in a set we can have unique values. Sets do not have keys. And we can have values that are primitive values or object references. I'll try to explain as we go and refer to this point, primitive values versus object references. But just to have like a frame of reference, for instance, is there any limitation on the keys that we have in an object? What kind of what must be true about these keys, or anything that you know about the keys of an object? They're unique. That's correct. And besides the uniqueness, any other properties from the keys?
I think they can be only strings or numbers.
Strings or numbers. In fact, let's try to do this. Console.log. Because console.log, let's say an object that has the numbers as the keys and the values the name of the number. So you can see here that we have an object with numbers as keys, but the keys actually get converted to strings. So they are unique, but they can only be strings. If they're anything other than a string, they will be converted to a string.
Hey, hi, Alejo. Sorry to interrupt.
Yep.
Hey, I joined the room earlier, but I didn't have my headphones on. I was in the kitchen. I'm so sorry. I missed. Then I
no worries.
So I didn't hear. If you were talking to me, I didn't hear it.
Okay, no worries. Yeah, we were just. I was just asking who wanted to go with you to create the breakout rooms, and also somebody asked, Joanne asked what you were working on, what you had planned for today.
Yeah, I mean that's a good question. What should we? What? Last time we did a mock interview, we could do another one. It could be a different person. I thought that was really constructive, useful. I like doing it. But,
I think that sounds like a good idea.
Yeah, it'd be cool to have somebody else try.
Cool. So I think I opened the breakout room, so everyone that wants to go has the breakout room button open and should be able to go. Let me know if it is not there. Let me just make sure. Yeah, I think Amin, Joey, Peter, and Ben, you guys should have that button there. Joanne, so they seem to be doing a mock interview. Are you interested in sending you? I can send you there. Hello?
No.
Okay. Cool. Let me see. Ben, try again.
Should there be a button somewhere? Usually it's like in the middle, right?
Yeah, like in the bottom bar. If not, maybe in there more.
Yeah, I found it.
Cool. Okay. Joy, I also sent you there. You should also have the breakout buttons to join. Oh, okay. So we were talking here about the. Let me share my screen again. Okay, so that's something that we're going to be looking at. The object has to have strings as keys. Okay, then let's keep talking about the set. So in a set, we can add any kind of value. We can add strings, numbers, booleans, arrays, objects, anything we can add to the set. Now it's important to know that the set is a collection of values. So in that, it's similar to a key and similar to an array. That is a collection, but it's specifically a collection of values only. And that each element might only occur once. We're going to come back to this value equality part, but let's just learn how to create a set. So we can create a set just with the set constructor. So let's say we can say let s equal, actually let's call it let's num equal new set. And just like this, we have a set. If you console log that, you get an empty set. It looks like an object by the curly brackets, but it's not. And let's take a look at how to add an element to the set. So to add an element to the set, we can just say, actually let's say nums, because it's a collection. We can say nums that add, and let's say I want to add 1. And let's say we also want to add 2. Run that. And then we have a set with 1 and 2. It looks like an object, but without keys, just the values. And that's it. Okay, so we can add elements with the add. We can add any kind of elements. Let's add an array. And so on. So this is the first method to add an element to the set. Just .add. Let's take a look here. Cool. We have a few other methods and properties. Most notably, sets don't have length. They have size. So if you want to see the size, nums.size. 4. They have some handy methods, like if you want to empty the set, we can say nums.clear. And since we're console logging after we added and we cleared it, we see an empty set appearing here. Question?
I just have a, sorry, go ahead, Marcus.
No, I'm sorry. I've got questions, but I feel like you're probably going to reach them just through the regular lesson. I don't want to jump ahead too much.
Okay, Joanne, maybe.
I was just wondering if the add and the clear, those are methods, right, of the set?
That's correct. Mm-hmm. Those are methods of the set. That's correct. We are not going to be implementing a set ourselves. I could actually show you a small implementation. I wanted to show you an implementation, but I couldn't find one that satisfied a condition that I think is key in sets. That is a valid implementation. And maybe what I was looking for is just too complicated and nobody has done it. But yeah, we can take a look at a simple set implementation after we get this one. So we have add, we have clear, we have nums that remove, I believe. Let's try removing 2. Oops, number 2. And see if I have a problem. Nums that remove is not a function, so that means I forgot the right method.
Delete.
Delete, thank you. So we can have that delete. Now we see the same set, but without the tool. What else do we have? We have entries. We have clear. Let's take a look at entries. Nums. Let's do console.log nums.entries. Oh wow, that is actually something I had never seen. Set entries. It returns what it looks like another set, followed by the sort of repeated values. Let's take a closer look at the documentation here. Entries. I see. Returns a new iterator object that contains an array of value for each element in the set object in insertion order. This is similar to the map object. So we haven't talked about iterators. An iterator is something you can use on a for-off loop. And I think it's something you can use in a for-off loop. And what is cool is it's an abstraction that allows you to do stuff like this. It lets you do, but here, this is a quick example. We have a set with foobar, one, and baz. And then we have the iterator. We create this iterator with my set entries. And then you can do set.iter.next value. And that's going to give you the first element. And if you do it again, set iter.next value, it gives you the second element, and so on. So it's a way in which you can traverse through the set by calling the next function on the iterator. Maybe later on we can talk a little bit more in depth. I haven't had a lot of exposure or have the need to look more deeply into iterators. Like I haven't seen like a practical use case that a more practical use case that I can show you. But just know that you can use it. You can if you have an iterator, you can use it in a for-off loop, and you have this notation to move to the next value. It's kind of similar to a linked list in a way that through the next you can get to through the entire list, and it returns the fact that it returns duplicate, like here foobar and foobar, is because the iterator's interface is more general than just for sets. It also works for maps, for instance. It doesn't work for objects. I don't think so. Let's check it really quickly. You can do this object. The objects must have an iterator somehow, because we can do a for-off object. We can do a for-off loop in an object, basically. Now let's move in from here. So entries. If you want to call a function for each element in the set, you can do for each, just like in an array. And here is a bit confusing also that you get like these duplicates. Here we can see that this is the function that we will pass, log set elements, which has value 1 and value 2, and then we pass in the set. This is actually not necessary here, but we see that value 1 and value 2, if we were on an array, what would be value 1 and what would be value 2 if we were doing a for each in an array? Does anyone remember that? If we're doing for each, yeah, that's actually, that might actually be worth looking into. If we have, actually we already have an array here. Say developers, and if we do developers dot for each, and we do A, B, and we console log, let's console log A and B. What is B? What is A and what is B? What would we see here? Any ideas? You should feel very comfortable with knowing what this function does and what the structure of this function. What is A and what is B? What would be a good name for A and B?
Variables?
Yes, they are variables, but what would I see if I run this code, if I run this line, what would I see in the console?
I think A is the element, like each element in the array, but B, I don't know, is it like an accumulator or the index?
Great. The second one, which is,
I don't know.
what
I
was
just
the
said
second
the
one you
two.
said?
Oh, accumulator.
No, that was the first one you said. It's the
That was the
index.
first one. I said accumulator or index.
So that's what
It
it
was
meant.
the
The second one will be the index.
Yeah, there you go.
Got it. So yes, this is the index. So if I run this, I should see the element followed by the index. We see Judy at 0, Corey at 1, Stephen 2, Jane 3. So for each is a function. For each receives a function whose first argument would be the element, and the second argument is always the index. That is true for sets as well. But sets do not have index, and sets do not have keys, like a map would have. So if we do, let me console this, comment that out. If we do here, nums that for each, and I say A and B, console log A and B, we will see this. Let's see, that A and B are the same value. That is just because for sets is the same one as for arrays, basically, and they wanted to make it sort of compatible, even though in sets A and B will be the same value. So just know that here, this is the element. Let's call it element, and let's say a element. So just know that you can loop over the set with a for each. Am I missing something? Oh yeah. Let's remove that for instance. Okay, so for each, let us iterate over the set as usual, as we would do on an array. Any questions or thoughts so far here? Okay, let's keep going. And we have, oh, this is a very important method that we're gonna use. Has, very simple one, and which one we're gonna spend some time. Actually, before we go into that, let's just briefly touch on keys and values. Keys and values both return an iterator again, and they are actually the same. They do the same for a set, basically, because a set does not have any keys. It only has values. If you call that keys or values, you will get the same thing. Yeah, you can see here. And again, that will give you an iterator, so that then you can do that next on. But again, I haven't seen a lot of very good use case for that personally. Okay, so the method has is the one important method which lets you check if a set has something. So here we can do if nums has 1, let's console log this. Nums has 1, that's true because the set has a 1 inside. Let's do, let me console log the set here. True. If I ask for the set to have, if it has 100, we get false. No, that doesn't break. It just gives us false. So this is very helpful in that regard. If it has a true, and it works exactly the same. Oops. Do we get? Is it running? I'm still running. Okay. Now we're gonna go back to the equality check is in here. Let's say this. We have this array. Copy it. I'm gonna check if my set has that array. And we're gonna run this. And the answer is false. It doesn't have that array. But you could argue it does. I mean, we're seeing the array inside there. The problem is that this array and this array are not the same array. They have the same content, but they're not the same array. They exist in 2 different parts in memory, and so on. And they have the same content, but they're not the same array. And that takes us back to, let's go back to the set, to the value equality. So because each value in the set has to be unique, the value equality will be checked. And what that means is you can think of it as it using the triple equal operator. So just in the same way, we cannot say this, console log, or not that we cannot say it, but it's not helpful. Let's have this object have a key called a, value 1, and we try to check that against another object that has the exact same key with the exact same value. We are going to get false because, again, they are 2 different objects. They happen to have the same content. They're 2 different objects. That doesn't happen with primitive values. If we have a primitive value, then the check is actually comparing. You can think of it as with non-primitive values, the triple equal operation is comparing if they are the exact same object in memory. Like if these two things are pointing to this exact same place in memory. When we're comparing non-primitive values, the comparison, even though like technically this one will live in some place in memory and this other one will live in some other place in memory, but there the actual values that are again, the value is what is getting checked, not the reference. So you can think of it as the triple equal operator checking the reference if two things are referencing the same thing for non-primitive values, and for primitive values, the actual comparison takes place. And we're gonna see one problem where that is important and helpful actually. So yeah, remember that you can't do triple equal on non-primitive values. Okay. So what do you think then this will give us? Let's say let array. Actually, let's change this to an object. Let's say maybe name Rudolph. And actually, I'm gonna copy this. Right. What we're gonna do is have dir, and I'm just gonna add that to the set. Nums.add dir, and let's just console log the set here. Let's take a look at that first. Okay, we have our object in there. We then saw that we cannot pretend to do this and get true. We get false for the reasons that we talked about. Because again, these two objects are not the same thing. They have the same content. They're not the same object. But if I do does nums has here, we should get true. And what was added was the reference to that object. Here we're asking if that reference to the object is in the set. Okay, now let's talk about the, okay, actually any questions on the methods? Yeah.
So a set can't be sorted.
Oh, that's a good question. It cannot be sorted. That's correct. That's a very good observation. It cannot be sorted. Other questions or thoughts? That is also true of objects. That it cannot be sorted. Right? Okay. Anything else? Anyone else? Okay, let's talk about the time complexity of these operations. What do you think is the time complexity of adding something to the set? to say one big O complexity. Maybe let's see. Start here.
Adding an element was the big O complexity.
What would you think? Yeah.
I would say it's constant time.
Constant time. That is correct. Oh, one. That is because sets, just like objects, utilize hashing. Utilize hashing of elements. Just utilize hashing is good. So what happens here is that this element gets hashed and that gets put somewhere in the set. Okay. Adding is constant time. Oh, I forgot to also do we have I feel like, oh, something I didn't realize is sets do not have a get method to get something from the set. I'm wondering about the has this returns a true or false. Yeah, there's no get, because I guess that kind of makes sense. With the has, you already know if it's there or not. Let me see. What is the return value of add? Return value, the set object, that is interesting. It says adding an element returns the set itself. Let's take a look at delete. Maybe delete might be what works as a sort of a get as well. Oh, actually no, it returns true if the value was successfully removed from the set. Otherwise, returns false. Has this returns true or false? Yeah, that's interesting. I didn't think about as I was looking at this earlier. We don't have a get method to get something from the set. In the way, well, we don't have a. Has is the only way in which you can check if something is in the set or not. And when we are checking if it's in the set, well, we really have it. We have the one, or we have the deer. Just interesting there. So from here, the most interesting one are add and delete is also constant. Also constant time operation, as well as has. Has is a constant time operation as well. So in that is very similar to the object. To iterate over, like for instance, entry or for each. What do you think this one is? Let's see. Khadija. What do you think is the time complexity of for each? Or actually even clear?
Clear will be constant.
Say that again.
I think it'll be constant too.
Constant.
Oh no, maybe
it won't be constant. Yeah.
It will be constant.
It won't be constant.
No, I think it's gonna be linear, not constant, because it's gonna loop through the set. It has to find it first and then clear it, remove it.
That's correct. Loop through the set and delete each element. That's correct. We could implement it clear ourselves if we do for each, and on each one we delete the element. Great. So yeah, that will be, this requires an internal loop. For each is a loop. The other methods that we are not going to touch a lot are entries and entries, values. Those are also loops as well. Okay, so this is almost constant time. Well, it's constant time for a lot of operations. Actually, kind of the same that for objects, so that is cool. And the question then now is, when would you want to use an object, or when would you want to use a set over an object? Does anyone think of any cases? I guess objects. These are key value pairs. These are only values.
For maybe keeping similar bits of information together that don't necessarily need to be sorted in any way, like car colors or I don't even know.
I think that is a good example. I mean, that is something that could also apply for like an array or a linked list as well. Like you can keep collections of things. Here, I guess like the key differentiators are the fact that they must be unique. You cannot have repeated ones, and you cannot have, and that what you can store is of any type. And I was trying to find some like exercises that we could do with sets. I have some. I think I didn't find like a lot of them, but I have some that we can take a look at here. But before we do that, let's compare. Let's keep talking about here, like some of the differences in here. So what about if we compare a set to an array? What do we know? What do we know about arrays?
An array has an inherent order. There are indexes to an array.
So it's an index. Let's say we have indices, and that we could say that is also something we can express as random access. An array allows to have random access in constant time of one random access with any index that we know. We can go there really quickly. As sets do not have random access, you have to get an element or to check if an element is there, you need to know what that element is. Sets do not have indices, for instance. So let's say like, no. So we don't have no indices. And what else? something that we just talked about. An array you can have duplicates, can be sorted. Those are no for sets. What is something they have in common? Something in common between an array and a set.
They can hold any type of information.
That is good. Yeah. Can hold any type. And do that one here as well. And one important one is the arrays are values only. You cannot have keys or anything else in an array. You can only have values. So in that way, an array is similar to a set. And an array and a set is similar to an object in providing constant time access and addition, where that will be different for an array. Okay. Anything else? Joanne, maybe?
I was gonna say, does looping count between?
Oh yeah.
Array.
That is correct. Yeah. Looping. So actually, and now that we're thinking about, and this is actually a good way to loop over values. That is true over values. That is also true for objects, right? We can loop over the objects. And this is a great segue for the next point, which is, well, we said sets cannot be sorted. Objects cannot be sorted. But how is it possible that you are able to loop? If they cannot be sorted, in what order do you loop? Right? Like, that is something that we hadn't seen or talked about much. But if they cannot be sorted, when the loop, how would the loop happen, like in a random order? Like if we look at, we know how to loop it over an array, and we know that we start index 0 and we go to the length of the array -1, right? That's a very particular order. When we loop over an object with a for off or for in loop, and when we loop over a set with a for each loop or a for off loop, those loops must happen in a particular order. And some other, actually, I don't know if this is fully true. I know that the elements in the set or in the object are not in a, I want to say, an established order as they are in an array. So an array is very specifically an ordered data structure. So what I was going to say is that in other languages, or here's a better way to say it, order in objects and sets is not guaranteed. And that is true for JavaScript and for other programming languages. However, JavaScript, and I'm not sure if this is true on other languages, but in JavaScript, when you're looping over a set and when you're looping over an object, those iterations will happen in a particular order. There is a great article that I'll share later. Object reversal JavaScript. I think I'll try to find it. I forgot the guy that wrote it. Might be this one. Yeah, this is the one. Let me just share it right now in online resources. Really great, a really good read. This guy explained that really well. And I think it's something that is a fair question of a JavaScript developer on an interview. But I will give you the short version of that. Basically, and they are when you do a for off or for in loop on an object, the loop will go first on numerical order. So if you have keys in the object that are numbers, those will visit it in numerical order. So 1 will go first, 2, 3, 4, and so on. If you have a 10, then that will be next. Once it finishes with the numerical object, the numerical keys, it will go in insertion order. So whatever key was added first, that key will be printed or visited first. And a key that was added later will be printed or visited later. I think maybe we can go back to that object. For the sets though, the loop happens in insertion order. So we see that is why we see when we console log the set, that is why we see 1 before the 2, true before the 2, true after the 2, and the object last, because it's being printed in insertion order. And when we do a for each, actually let's do this loop. Let's do for element of nums console log element. Let me pick. Oh, wait, hold on. Let me just double check this here. I have seen this, but maybe I'm. Oh, actually, maybe is, let's see, loop over set JavaScript. I had seen it. So there is the for each. That's one. Yeah, like this. For let I of I. Well, let me actually see. Oh, that here we'll learn something new. That only Firefox version 13 supported. That is interesting. I think we can do it for each function. Let me take a closer look here at this one. I think this was one of the resources that I was looking at. For each. Yeah, like you see this loop here. Let's try this one out. But it might be then a Chrome thing. Let's call this one out. I'm actually then now confused because this one did work. We have our set. Oh, does anyone see the problem? We can loop with a for off. Does anyone see the problem that I have with this loop? And the problem that I have with this loop is not in this loop. Nothing.
Is it? Did you delete everything?
Okay, yes, that's what's going on. Where am I deleting everything?
It's at line 45.
Line 45. Is correct. Thank you. Let's see now. There we go. We have our elements there. This set is a bit better. It's a bit pretty because it has it has emojis inside. Cool. Let's have that one as well there. Okay, so here we see that when we let me comment out. Actually, I'm gonna remove this one. When we comment out, then I refresh accidentally. The point is the order in which we see this happening. We see that we looped in the insertion order. So first we added 1, then we added 2, but we removed 2 here before that. And then we added true, and then we added Rudolph, the deer there. And here, this is a console for true. Let's actually get rid of that. But basically, we are seeing the loop going in the insertion order. So just remember that for the sets. It's possible to iterate over the values, and that iteration will happen in insertion order. And that's it. So you think of it like you cannot reorder the set because the set will always be ordered or it will always be iterated over by in insertion order only. Okay, so that is pretty much it on like the stuff that we need to know for the set. But I'm curious about any questions or thoughts before we do an exercise.
Just trying to think. I guess you could use this. I'm just trying to think of ways you could use this set.
Okay.
For perhaps holding on to, again, because things are unique within a set. Could you use it as a check for like storage? Like, could you use a set in your state where you are holding on to, or maybe not your state, but if you're holding like a way to check without having to throw to, like, I guess a fast way to check if something's already inside of a set. So if you have a like a hashtag coming in, you'd have constant time check to see if that exists, if and then use the, and then if not, like add to set.
Yeah, I think I'm not sure I understand the example with the hashtag, but you know, let's just look at an example. So what would you do? What would you do if you asked to remove remove duplicates from an array? How would we usually do this? How do we usually do removing duplicates from an array?
Well, I guess one way would be to loop over the array, and if it encounters a new, I guess building a like a copy of the array as you go, like build a variable that's like new array, and then as you loop over, you can oh, actually no, that's even better. So as you're looping through, you're checking against, have you seen this already? Then if so, then you can
Okay. And how would we do that?
Pop, but how do you?
but how do we do it? Like more specifically, how do we check if it's
Like
already
you can
there?
keep track of the ones you've seen by adding them to a hash map, an object, and then so like if you haven't seen it yet, you add it to the object. If you have seen it, then remove it from the array.
Okay, that's correct. Does that make sense for everyone? Give me a thumbs up if it does. Great. Okay, great. And what will be, so we will end up with an object that looks like what? So what would be the key and what would be the value? For that object, Brianna maybe.
I don't know. The value doesn't really matter. Oh, I was thinking like you just remove the duplicate. Like if it's already in the object, you remove it right there. Like I don't know, use splice or something or slice.
Okay.
But we can like have the key be the element, and then the value could be like 1, and then if you saw it again, you make it 2. And then I guess you could look through the object and be like, oh, but you're removing, no, you want to remove the duplicates, right? So
that's correct. Okay, I think that can work. Joanne, I think you were gonna say something too.
No, I think Brianna had it covered.
Great, cool. So basically the approach there is we add the numbers to the object as the keys and the value, how many times we have seen it. So if we're looping over here, we go 1, we saw that one time, so let's put it 1 there. We go to 2, we saw that one for the first time, let's go there. Then we see a 1, then we check the object, it has a 1 already, so let's just increase the counter there to 2. And now we move on to 3. 3 is the first time we see it. We put a 1 there. Then the next one is this 2. 2, we already have it in the object. Let's then increase the count. We go with 0. 0 is the first time we see it. We add it to the object and initialize it with 1. See 7. We see it for the first time. We added that 1 as the value. We say then 7 again. We increase the counter for that to 2. And if I understood correctly, Brianna then said, okay, then we build this object. And then after that, we can just loop over the object and see which ones have 1 as the count and put those into an array. Does that make sense for everyone? Okay. Yeah, thumbs up, appreciate it. Okay, but so that works, and that is a perfectly valid approach. But do we need to count how many times we have seen an element? Or could we do it without counting?
That's what I was saying, Alejo. I'm like, you don't really need, oh no, but yeah.
Okay, so
I was saying like you can remove it in place. I just don't ever remember how to do that. Like if you just slice.
Oh, but actually, even without slice, we will still not use slice.
Oh, so I don't know.
Okay.
Wait, do you mean like still use another array and push into that one and?
Yeah, we'll have like an output array. Let out equal empty. But here, any other ideas for a value that we have had in the past?
No, I don't know.
Or do we need to count? We have seen this 1 time, 2 times, 3 times.
Yeah, no, you don't need to count. Like just
We could swap a Boolean where if you've only seen it once, if it's the first time creating it, it starts as true. But if it encounters it again, it swaps it to false.
And for this example, when it encounters it again, it swaps it to false. Okay, that could be. and then we'll push only the trues, right, instead of the ones. What if what I'm thinking is, if it's for the first time, we see true. Once we see for the second time, then we don't push that one. For the first time, we just keep, this will keep track of basically if the elements we have seen so far. And if we have already seen an element, we just won't push it. So we see one, we haven't seen one before, so we push that one. We see two, we haven't seen two before, we just push that one. We see one, we check if we have seen that before, we have seen it, it's true, then we don't push it again. We see three, actually then, wait, hold on a second. I think I'm wrong here. I'm wrong in the output here. And I apologize. I think this might be why I was getting some confusion. This is what I would expect to get. No duplicates. Okay, but the point I want to get at is, can you solve that problem using a set? And I'm going to share this link here, and I want you to try it out for 5-7 minutes or so. I'm going to share it here in Zoom. And I want you to try to use a set for solving that. Is that a reasonable ask? Or give me a thumbs up if that does not make any sense. Okay, let's try it out. And oh, but don't modify this one. I send you the link so that you can copy the code and create your own REPL. I don't know if REPL has a fork option. I think they do have a fork option. Let me see. I think I remember seeing, oh yeah. No, version control, no. I think they used to have a fork option. Oh, I don't know why mine doesn't have this button for forking. That's interesting. So let's take about 5 minutes for that.
Does the output have to be an array?
Yes.
Okay.
Okay. Give me a thumbs up if you think you have something. Okay, we have two. Okay. Then maybe one of you can share your screen, but before we do that, I want to hear a little bit maybe from the rest. Or or actually, let's do this. What we can do um, is if you feel like you don't have something, uh, give me a thumbs up if you don't have something, or you feel like you didn't finish. Okay. Does anyone have like Okay, so Suzette, Joanne, Jonathan, Kathy, or Khadija, did you guys attempt it at least? Okay. I see Joanne, Kathy, Khadija. Okay, so let's do, so what I want to do is actually, Suzette, if you could share what you have, and then Sergio we'll take a look at what you have, and then Sergio will guide us through how to get it to work.
I gotta run to the restroom. So can somebody else?
Okay. Let's do Kathy.
I got it to work.
Okay. Great. Maybe then Douglas.
All right, here, let me quick share my screen. This is about as far as I got. I realized that we didn't want to do this, so I started building a second version that was closer to what you wanted, which was to keep output as an array. So I got as far, I haven't tested this, but my idea was that I'm going to loop over the length of my, I'm going to sort the array, and assuming that we're only getting numbers coming in. And then if the,
hold on, so if let me interrupt you there. We're not going to look at the second solution. We're going to look at the first one. So Riani or Sergio, what is going on the first solution? Why didn't it work? Or could any one of you walk us through first, like, and or why it doesn't work?
When he created the new set, he didn't use the parentheses.
Okay. So what does he need to do to fix that?
Add the parentheses after set, right?
Okay, let's try that. And let's try.
I didn't get the rest. Let me see. If output has, yeah, I don't know.
Okay, let's run this and let's see what we got.
So he got his set, right?
Okay, we got the set. That's correct.
Output array.
But then we need to put it in the output array. Any ideas for that? Or any ideas on how we can change this, the rest of this code?
Does he need the if statement?
That is a good question. Sergio, what do you think? Or Kathy?
If he needs the if statement. That's the question.
That's correct.
I don't know. I did the same exact way, the first part. So
okay. Okay. Brianni, what do you think do you think we need the if statement, or do you think we don't need the if statement? This is actually a good question.
I don't think we do.
I don't think we do either. Let's remove the if statement and let's see what we got. But leave the
output add, yeah.
And then let's try it.
Yeah,
okay. But why is it that we don't need the if statement?
I guess because if you already insert something into the set and like that value is already in there, it won't let you add another one with the same value. So it only inserts it once.
Oh, I didn't get that part of the set. That's cool.
So if you try to add a duplicate value, it won't add it.
So it's basically built to solve this problem, this exact problem, the set.
Yeah, but it doesn't give you an output of an array.
Oh, I did that with a for each.
Yeah, same. I just pushed it into an array.
Okay, let's do that. So maybe, Sergio, what does Douglas need to type?
So he's going to create another output, which could be, I don't know, output array.
Okay. I would say instead of calling output the set, I'll call this output. Line 4, I will call it like, I'll call line 4 out set or S, just S for short for set. And then output will be the array. That's correct.
Yeah, create an empty array. Name output. And then S dot for each with a capital E. Open parentheses, and then we'll put element, actually between parentheses too. LM is fine. Then the arrow, open curly brackets, output dot push, open parentheses, LM, and then return output. That should do it.
Let's take a look. Great. Cool. So does this make sense? Any questions, thoughts? Mm-hmm. And does anyone have anything different? Kathy, maybe? Oh, actually, Douglas, could you leave it up?
Sure can. Give me just a second.
Kathy?
There it goes.
Instead, I did well, if you look at number line 4, I did let S equals new set, and then I put array inside.
Oh, yeah, that's great. You discover that. That's great. Actually, then do you want to show your screen?
Sure.
Okay, let's do that. Because that is cool. That's actually exactly where I was gonna head next.
Hold on a second. I have a lot of tabs open.
That's common. That's common among developers. Oh, awesome. Yeah, you have something going on here. So do you want to tell us what this is, and I can support you?
Well, I was confused at first on how to use set, so I just put array.
Mm-hmm.
And then I got, since set only returns unique elements, it'll return the 1, 2, 3, or 7 without having any duplicates. And I wasn't sure how to make an array, so I did. I used the spread operator.
Mm-hmm.
I don't know.
Right, and that's it basically. In fact, like this problem could be solved in one line, and this is really neat. Yeah. So the next what we're talking about here is that then to the set you can pass in an array, and that will automatically get rid of the duplicates. And then with the spread operator, we can just spread the set inside of an array, and there we got what we needed. Great. This one, let me show you here. I was thinking that there might be another way as well, but let's let me share the screen here. Share. Let's make this bigger here. Move this around here. Move you guys around here. Yeah. So this we could do if we do something like this. Remove dupes IRA. Say new set, and we pass in the array, and we do something like this. This should technically work.
Whoa.
New set. Let's try it out. Oh, great. Basically, we create the set, and then we spread it immediately after into an array, which is the same thing that Kathy had. Something to learn here is the set, the spread operator also works on a set to spread the values. I wonder what happens if we do this. If we try to spread it into an object. Oh, but since curly brackets have special meaning here, I guess we'll need to do something like this. That. Maybe this might not even work. Oh, we'll try to spread a set into an object. We get an empty object. So that doesn't really work for. But this is exactly the same stuff. Yeah, Kathy has. And what that brings us back to the constructor. The constructor, we can have an empty set just like this. Or we can pass an array, or actually, I think it's any iterable. Let's see. Sure. Set. Set constructor. Yeah, we can see here when we're creating a set with those with this array. Okay. Any iterable. An iterable is an object. Any iterable object is passed. All of its elements will be added to the new set. If you don't specify this parameter, the value is null. The set is empty. An iterable object. Let's see if we can get a little bit of what an iterable object is. Oh wait, this took us to the for off. Iterable objects. Yeah, this is a bit. We don't need to get into this. Yeah, let's not get into that at this point. Well, you can think of anything that you can iterate over, but in a particular way, can go in here for the new set. So that's great here. I was also thinking for this example. Let's try this. Let's say we have let output empty, and then we say let num for let num of array. If we'll need the set equal new set. If s that has element or num, this is I think this should be another way. Else as output that push num And regardless of those two, let's do as that add num turn up. Let's see if that gives us the same thing. Yep. I guess we could do, instead of this, if it doesn't have it, let's push it. Regardless, add it. Okay, great. This is a problem, and I think I wanted to highlight something that Brianna said, like about like whenever you're trying to use an object for something and you realize that the key or the value doesn't matter. It doesn't matter what it is. Then that's probably a scenario where you want to use a set, where the key or where the value is like irrelevant. Okay, so this is one example of that. I think. Okay, let's see. I wanted us to look at some other exercises. Yeah, I want you to try to do this. Oh, I should have kept the other as well. Let me put everything back to have two solutions here, just for reference later on. Okay. Okay, so I want us to try another exercise. And that is implement a const function union. Let's try union first. S1 and S2. And what this function should do is it receives two sets, set 1 and set 2, and it should return the union of those two sets. What do we mean by the union? So if we say union, let's say let A, and this is a new set, and now that we know how to create it with an array, I'm just going to say this. Say 5 and 9. B 0. Oh, this is interesting actually. Let's say 3, 4, 8. What this should do is return a new set. Return a new set which has all elements of both. So the new set will be something like when I call union on A and B, the new set will have something like 1, 0. The order doesn't matter in this case. 3, 4, and 8. This specific order in which I wrote them down doesn't matter. But so let's take 5 minutes to write this function. The union function that performs a union in two sets and returns a new set that has all the elements of both sets. Was questions or thoughts on this? And if you're done with that one, these are also some interesting ones. The intersection, which is returning a new set which has only the common elements of both sets, and the difference. The difference has a direction where if you pass in set A and set B, it will return all the elements from set A which are not present on set B.
Are we allowed to alter the input sets, or are we to return a brand new set of the union?
A good question. Return a brand new set.
Okay.
Do not modify the original. And give me a thumbs up if you're currently like attempting it. Okay, great.
The union one or the intersection one?
Any of them. Great.
Sorry, how is the difference? The elements that from S1 that are not present in S2?
Let me take a look. I always have to think about it. Yeah, as return the elements that from from the set A that are not in set B.
Okay.
Give it 4 more minutes, and so I see that I think some of you might be attempting some of the other ones, which will be great. Okay. Any? Give me a thumbs up if you did at least one and it works. Nice. Okay. Cool. Okay, let's take a look. Suzette, do you want to share your screen? Which one did you do?
I did the union one.
Okay, let's take a look.
Yeah, I see it.
Uh-huh. Oh, nice. Really cool. Using the spread operators right off the bat. Spread S1 followed by S2. Just create a new set with the combined version of and return the union. Awesome. Cool. Does this make sense to us? Great. Okay. That anybody did it any other way?
I did 2 for loops.
Let's take a look at that. Mm-hmm.
Both of them, and then added them to the merge.
Great. Awesome. So you're just looping over S1, looping over S2, adding them. Great. Yep. What was that?
I said, and just adding it to the new set merge.
Mm-hmm. That makes sense. Do you think, does anybody, what is the time complexity of this? Or is it better or worse than Suzette? Any ideas on that?
Wait, the time complexity of doing what?
Of Suzette's approach to the union versus Khadijah's approach to the union.
What was Khadija?
The two loops, for of loops.
When you use the spread operator, is that like making a copy, like looping?
Mm-hmm. That's correct.
So it's the same thing.
And what would be that same thing?
O
of what? O of n?
Yeah.
Okay,
Or,
that's half.
I guess O of n plus O of m.
That's correct. Or just combine O of n plus m. That's
yeah.
correct. And what is n and what is m?
N is the length of S1 and m is the length of S2.
Mm-hmm. That's correct. So both are the same exact time complexity, O of n plus m, and exactly as Brianni expressed it. Great. Did anybody do any of the other ones? Intersection, difference?
I didn't get to work on it. Could you give us a few minutes? I want to do it.
Okay. Okay, we can take 5 minutes. But Douglas, do you have a question or? Okay, let's take 5 minutes. Let's do this. If Brianni, you're gonna do intersection, right?
Yeah.
Okay. Somebody else does difference. Who wants to do difference?
I'll try. I'll see if I can get it to work.
Okay, right. So let's take 5 minutes, and then let's take a look at those. And just in case those are easy, I'm gonna add in one more here. The symmetric difference. Oh, and also you might need to modify the original sets A and B so that you can try intersection or difference. And then once we're done with this, we'll just see you one more example, one more like problem where a set is helpful, and that would be it.
I'm sorry, I thought I grasped what the difference is that I'm trying to create. Am I trying to find, because I feel like the difference between two sets is going to be all the unique numbers, or am I wrong?
All the unique numbers. Let me think about that.
What
Oh,
is the difference?
in this case that is true, and the difference will wait, set A will return elements from set A which are not present in set B. In this case, that's why I said we will need to change A and B to try the other ones, because in this case, the difference between A and B, which are all the elements of set A which are not present in set B, will return basically set A in this
Okay.
case. But let me give you a better example here. If we had here, let's say we have 3 here, the difference will return all elements from set A which are not present in set B. So difference should return. Let's add one more. Let's add like A here. So this between A and B should return 1, 2, and 9. Because are all the elements on set A that are not present on set B.
Thank you.
Mhm. Okay. Brianna, do you have the intersection?
Yeah, you want me to share my screen?
Sure.
So first, I did it like this, where it says intersection 1. I created a whole new set and I looped over the first one and I created an if statement that says if the second set has the current element, then add it to the new set, and then I just returned the new set at the end. But then when you said that we can like change the original sets, I created a second function which I also looped through the first one, and I said the if statement says if the second one doesn't have it, to delete it from the first set, and then return the first set.
Cool. Yeah, this is good. And on this second one though, yeah, it will depend on like if you're allowed to modify the original input, because here you're modifying S1. So if anything else was using S1 outside of this function, that will be modified forever. But yeah, these are, I'm glad that you actually wrote 2 actually. Questions or thoughts about this one, the intersection? And I always have to like think about it. Returns a new set which has common elements in both sets, basically. So the intersection is what are the common elements in both sets.
Yeah.
Great. Any questions or thoughts on this? Anyone? Okay, let's take a look at Douglas.
Sorry, struggling to find my controls.
And you were doing the difference. Let's take a look. So the difference is return all elements from A which are not in B. So let's take a look here. What do you feel? Okay, let's see. All elements in A that are not present in B. So you have 2. 2 is not in B. That's correct. 4 is not in B. 5 is not in B. This is correct. And that's why I said that difference is sort of directional, because it's A and B. If you swap them, then you're going to get a different result, which is expected. Great. Does this make sense? Any questions, thoughts? Okay, let's move on. I'm gonna share the screen here. And actually, I realized that there was one example that I wanted you to run through, but I actually think we're gonna be right on time. But so there is this example basically, where a use case that could be a bit more real for sets, and we can use one of your functions. For instance, let's say we are asked to find, we have these 3 pieces of data: employees, gym members, and developers. And we're asking for all the employees that are gym members and developers. How could we do that with what we just saw?
We could loop over employees, since we know that that's the one with the most content inside.
Mm-hmm.
But as we loop over employees, we're going to ask if the element it's looping over at that iteration has if S2 or S3 have that, like if it matches there.
Mm-hmm.
And if not, or if they do, push that into a new set.
Right, and with the operation, is there any of these that will help us there? Union, intersection, difference.
It would be intersection, I think.
Mm-hmm. It will be intersection, right? But then how would we do that? Let's say here. Actually, let me lower this here. So, what should I type? And if I have, oh, actually, I don't have intersection here. Can somebody send me intersection? Oh, but it will need to be on Slack. Brianna, you were working on intersection. If you could send it on Slack.
Do you want both, or I don't know?
Only the first one.
Okay. I think I could just post it on the repo.
Oh yeah, that was even better. Great. Thank you.
Oh my gosh, now the repo is refreshing for me. Okay. I just pasted it at the bottom. I don't know where it is. Alejo, refresh. And you're on mute.
Thank you. There it is. Okay, so here, how many intersections do we need to do?
So which one, what do we want again?
We want the employees that are both gym members and developers.
So what do you mean?
So we want to find, like, from this set of data, we want to find all the employees that are gym members and are developers.
Are these sets though, or are these arrays?
These are arrays, but we know how to turn them into set really quickly.
Okay.
So basically, what we could do is, let's say, let m dev, let's do gym. And if we want to find all the employees that also go to the gym, we just need to do an intersection, right? So we can do intersection 1 with employees and gym members. And let's console log that. Oops. Oh, right. Oh wait, what? Diff is not defined. This is this problem here. Never defined diff. And also, there's something else. We need to create this set, new set. So that we call it something like this. And let's take a look now. Okay, so we got Corey, April, and John. Those are the employees that are also gym members. And then once we have that, we want the employees that are gym members and developers. We can just do another intersection on gym and developers. Then intersection, but we'll take employees that are gym and employees that are developers now. But okay, so this already is a set. We need to turn the developers into a set. New set.
You need a console.
Oh, thank you. Gym developers. And then we found that Corey and April are the only two employees who are both gym members and developers using intersections and a set. Questions or thoughts on this? This is just like a more, hopefully a more real world example where a set can be helpful. When you want to check that, how can I summarize this? Well, you want to check if data is present, but I think that's too general. Yeah, I'm not sure how to more better explain that, but I hope you get the idea of like what we're doing here. In fact, like this actually looks like this intersection looks like what that we know in SQL.
Join.
A join, right? Where you can have where you, for instance, when you have like shows and this is actually from the CTA, shows and show users, where the show users is a table that connects shows to users, and we're looking for a join to join where the user ID matches. We're looking to join. That's actually kind of a complicated example there. Let's say we have, let's say we have a table of schools, and we have a table of here. We have a table of subjects and a table of teachers, and each subject has an ID. And in the teacher table, we have each teacher has a subject assigned, and in that way we can perform a join to know what teachers belong to what subjects, and if we're interested in anyone in particular. So yeah, the intersection is somewhat similar to a join. I was thinking of the union. The union will be like if we did an full outer join. Yeah, I think that will be the closest, and so on. Now, the last example that I wanted us to look over this is actually the essay question, where a set is very helpful. And I'm thinking about how we can do this. Actually, Suzette, would you like to explain this part if you want?
Which question was it?
Oh, the finding a loop in the linked list.
Okay. I still have my answer, so I can show that.
Sure. Yeah.
Or do you want to just?
I guess let's just do it here. So basically, this is a staple question in linked list. Find if a linked list has a cycle in it, which is when a linked list points back, with any node in the linked list points back to an earlier node. So I had asked this question of Suzette, and we were working on it. And the way that actually she came up with to solve it was to have an object, and the object you keep the values of the nodes. So in this case, if we have that object, we will have like 3, and I don't remember, Suzette, were we counting or just putting true?
We were counting, because if it repeated, then
okay, so you had something like this. You saw 3 and you saw it once. You're iterating over the linked list. So then you move to 2. You saw that once. Then you saw a 0. Then you put that as 1. You do 4, and you saw that once. And then you see after, because we're iterating over the linked list and we're moving always to the next pointer, when we're on -4, actually this is -4. When we're on -4, we will see 2 again. And if we do 2, well, we'll just check our object that I think we call something like scene. We could check our object, and if we already saw a 2, then that means that there is a cycle there. Does this part make sense for everyone? Give me, all right, what can I clarify here?
This though is only if every integer in that linked list is unique. So we didn't, like, this was like what we initially did. So after that, we had to take into account that there would be repeated numbers or values in the linked list in this question.
In this question, that's correct. So basically, what we're doing here is, actually, let's do it. We have let scene empty array, empty object, and let's say, well, I'm gonna change this to node. While node, okay, let's say current here. While current if current, if we have seen current dot value, then return true, and then advance the current equal current dot next, return false. Let's take a look at this. So this is taking longer than usual. Time limit exceeded. I'm trying to see if there's anything else. Oh right, I forgot to add it to add the current value to the scene object. Equal 1. So this is already seen. Not seen, add it, and just move to the next. Okay, does this make sense? Thoughts or questions on this? Let's see if we can console log. See. Console. The code doesn't let you see the console. Oh, actually, maybe it does. Oh no. I got excited. Okay, questions or thoughts on this? So far, does it make sense? What can I explain again? This loop is just iterating over the linked list. So the point that I wanted to make here is that this works as long as the linked list does not have repeated values. Because once it has repeated values, let's say we had, wait, can I? I'm not sure. Yeah, I can annotate here. Let's say we have 4, and let's say after here we have a, so we have a 2 here, and let's say then we have a, I don't know, a 7, and then is this 7 the one that's pointing back to this 2? And let's imagine that this is not, the 4 is not pointing back to 2, instead it's 7. The problem here is that then we have nodes that are different, but we have a repeated value. So in this, our solution will not work because when it says these 2 here, when we come to this 2, it will think that we had already seen that 2. Well, we saw that 2. We saw the value 2, but this node we haven't seen. And that's sort of the difference there. We saw the 2, but we haven't seen these 2. This node, this is a separate node. So then, in fact, if we do this, if we try to run this code, if I'm trying to submit, we see that we get the wrong answer for some examples. I think this one might be the empty. Wait, what? If we have a linked list with only 1 and 2, it should return false. and my solution returned true. Oh. Wait, actually, this one is. I'm thinking if this one is S. No, it's not that one. There is no cycle in the linked list. Suzette, do you see any difference between this one? I know that I have some differences, but I don't remember exactly where.
Yours, I mean, in your same object, you didn't increase the value, like if you saw it already.
Yeah, but that shouldn't really be a problem though.
Yeah. I'm looking at that.
Is it that here? I think I don't remember if this was current dot next.
Yeah. It was.
That was current dot next. Let's try this. Start with a sample case. Cannot read property next of null.
I mean, in the example you see there, it points back to the one, but it doesn't seem to have anything after. Like it doesn't seem to be.
Also, I forgot an edge case here, which is if not node, return false, which is this case. Okay. Okay, so here we're doing if the node is null, then just return false because we don't even want to check. And this is the case where I wanted us to arrive at. This is the case where this linked list is just represented by an array or by this. This is not even an array. This is just the way that the input works. I don't know why this is getting me that, but basically we have a linked list that has all these values, and here values are repeating. Let's see. Is it is it actually repeating now that I'm thinking about?
Yeah, yeah, it has -21.
-21 here at the beginning and -21 here at the end. Is that the only one?
I think there's more. The
-12. I see a 5. This 5 here. This 5 and 5 here. But the point there is that this fails because our object is having only the keys are the values of the node are the keys in our object, and this is a problem we can solve with a set. This has a different solution as well that is more efficient in space complexity, but we can solve this one with a set. If instead of scene being an object, we have a new set, and what we could do then is instead of this being the object notation, we do if scene that has the current element, then return true. Otherwise, scene that add, we're gonna add the node itself. This is that's what might be a bit more. They might mind bending a little bit, where the fact where we're adding the entire node to the set. So if this is literally saying if we saw that node, not the value of the node, but if we saw that specific node, then that means we have a cycle in this linked list. Because as we saw here in this example, at some point we will get to the exact same node. that we had seen earlier. Not the value, but the actual node. If it's that exact same one, then that means that we already saw it and we are in a cycle. Otherwise, add it and then just move the next. Let's try this out. That will work there. Let's submit. And then we have a working solution. This is, oh, you can see I tried to do this 2 years ago, and I got mostly wrong runtime errors and wrong answers. Questions or thoughts on this one? So the cool thing about the set is that you can determine whether something is part of the set or not in constant time. And the set can have primitives or object references. And because the way in which this is working, basically, we added the node 3 to the set. Let me see if I can go here. We added the node 3 to the set. I'm just gonna represent like, actually, yeah. We added the 3 to the set. Then we move on to the next one. We add 2. We add 0. We add -4. Then we add another 2. Then we add 7. And in those cases, as we were looping, we were checking if that node was already in the set. Up until we got to 7, none of those nodes was in the set. Once we go to the next of 7, which is node with value 2, and it's an earlier node, we're going to ask this, does the set has node with value 2? And this is node with value 2, but specifically this node with value 2, not this one. They are two different nodes. If it has that node, then return true. And that will then make it crash. Like we could say this is node A, this is node B. There's two nodes with the same value, but they're actually separate individual nodes. Questions or comments?
I still don't, forgive me, I had to step away and I missed a chunk of the beginning of this whole explanation. I still don't understand how you can check to see that at each iteration that a node is inside of, like, that's the part of this I don't understand at all. Mm-hmm. Isn't it what is a node under the hood, I guess, is a better question. Is it not an object? And how do you, so is it just asking, does the value match? Like, what is it checking against?
Mm-hmm. So it's checking against, that is a good question. So sets works, we talk about sets working with hashing under the hood. So what happens is that each one of these nodes gets hashed and put into the set. The hash of this node 3 will be, just to put an example, let's say this a simple hash. Let's say the hash for that is A and B, AB. The hash for 2 can be something all random. Let's say X and Z, and so on. So each one's got hashed, but the hash for this node will be different from the hash of the previous node. So so in this case, it will, let's say the hash was, let's just say CP, just to put an example. The hash is different because of the, even though the value is the same, the place in memory that these two objects live in is completely different. So you could think of it as comparing for the hashes, basically. I don't know if that's a bit more clear. Or anyone wants to try to reward that or explain it in a different way, feel free. So we're adding nodes to this set, which are objects, as you said, Douglas, and we're just checking, have we seen the reference? Have we seen the reference for that object here? Have we seen that exact same object? Not the value, but the combination. You can think of it as the combination of the value and the place in memory that is at. Mm-hmm. Other questions or thoughts?
Is it possible to add a console log inside that loop underneath the counter?
Let me see. What line?
Line 23. So if you
Here. Can we put a console log here, or you mean here?
Yeah, right there.
And what would we want to see here? Console log what?
I basically want to see how it adds the nodes, like the set.
So you want to see like scene.
Yeah.
Right. So I think this won't show us. I think Suzette, or did you create? Oh, actually, it does shows up. What is this?
Hi, everybody. I'm heading out.
Good night, Ben.
Take it easy.
Thank you. This is interesting. It does like so. VS LeetCode is not very good at letting you console log stuff. We will need to create. So my recommendation will be create your own linked list and link one of the nodes to put the next point to an earlier node, and then console log the set there, and then you will see what you will see. Basically, is a set that inside has each object representing the node, and in fact, that console log might actually be confusing because when you console log a node, it will console log its value and it's going to console log its next as well. And it will do that for some levels. So it might console log the next of a few different levels. But yeah, this set is a set of ends up having nodes inside. I think the best way I can say it is experiment with it, create your own linked list, link it back, and then console log it. Okay, so that is it for sets. I hope it was helpful. I hope whenever you get a problem, that you know that, for instance, you try to use an object and you realize that the keys are not, the keys or the object or the keys or the values are not necessary or irrelevant, that you consider a set, and that you have it basically in your toolbox as something you can use, especially helpful for removing like duplicates, as we saw, and so on. This is kind of like a version of that, duplicating in a sense that the linked list will point back to an earlier node having a cycle. Cool. So I'll make sure to, oops, let me see. I'll make sure to also upload the recording. momentarily. Let me, yeah. Okay, so again, that concludes our quick intro and teaser on sets. I think I had a few things, which one is, oh yeah, one is I'll be scheduling one-on-ones with everyone for next week, just to check in, see where you are, see if you're job ready. If not, what is missing? Let's get working on that. And if you're working on your personal website, portfolio, etc., or even personal project as well. So be on the lookout for that for next week. And another thing is, yeah, the fire chat that I had mentioned, that will be July 27th. I think I have mentioned it already. Amit Pillay, the CEO of the Trevor Project, and they work on suicide prevention for LGBTQ plus youth. And I hope to see lots of you there. I'll also remind us as that date closes up. And the last thing is this course that is available in Coursera for data structures and algorithms. I looked at the syllabus, and it looks really interesting. If you're interested in deepening those data structures and algorithm skills, I'll share it in the Slack channel. I think it was also shared in the core workspace, but I'm gonna share it here as well. Remember that Pursuit has free accounts for Coursera. If you sign up with the link that Tali has shared, and I think, did I share it again? I think I did share it again. I'll find it and reshare it. But that is pretty much it. Questions or thoughts?
I do have a question, please, about the Coursera. I noticed there is like a date limit for Pursuit.
I think it's the 31st of this month, July.
Yeah, but I don't know if like, I mean, if we sign up before this date, we're okay, and then we can purchase anything for free. I mean, get anything for free after, or we have to get those things now before this limit date.
That is a good question. I'll have to get back to you on that. I think I am inclined to think that's the former. You just need to sign up by that date, and because of that, then you are registered in partnership with I think the BMCC, I think, and then from there you can access the courses that are offered in partnership with them. Mm-hmm.
Until September or something.
Oh, there is another like date until then. After that, you're over. Is it over?
Yeah.
Where do you get that date from? Do you remember?
Slack message.
Okay, great, cool. So you have then from now until September to get enroll and learn something there. Okay. Oh, any final questions or thoughts?
Good night, everybody.
Thank you again for this, though. This did help out a lot.
Cool. I'm glad. That's the point. Okay. Have a good night, everyone.
Bye-bye.
See you all.
Good night.
Thanks, good night.
See you all Saturday.